So now in continuation, we'll do some more questions on surface area and volume. Look at this question number 4. What length of tarpaulin 3 meter wide will be required to make a conical tent of height 8 meter and base radius 6 meter? Assume that the extra length of material required for stitching, margin and wastage in cutting is 20 centimeter. Okay, so tarpaulin is that cloth, the very hard cloth, strong material cloth, which from which water cannot pass through, right? Okay, so now what is given here? Base radius of the tent is given, right? Base radius of the tent is 6 meter and height of the tent, that is h, is 8 meter, right? So this specification of the conical tent is given here, which is required to make radius 6 meter, height 8 meter, right? So from here we can easily find the slant height of the conical tent, right? So find out the slant height L, which is the square root of r square plus h square, right? Now put the values. R, that is 6 square plus 8 square, right? That is 36 plus 64, right? So L is equals to square root of 100 meter, that is 10 meter. So in this way, we have found out the slant height of the tent, conical tent, which we have to made using this tarpaulin, right? Now, to make this conical tent, we should know the curved surface area of the conical tent, right? Okay, so if this is the tent, suppose this is the conical tent. So in which part of the conical tent is actually used, right? Which part of the tarpaulin 3 meter wide is used to make this tent? It is this curved surface area, right? Isn't it? So we need to find the curved surface area of the conical tent here, right? So write down curved surface area of the conical tent, which is pi r L. So what is the curved surface area of a cone? Formula is pi r L. Now put the values here. Pi is 3.14 given in the question. Radius is 6 and L is 10 meter, right? So this is this much pi r L meter square. Now if you can solve this, this will become 188.4 meter square. So this is the curved surface area of the conical tent. Now the material required, the tarpaulin required, is actually in making the curved surface area of the conical tent. That means area of the tarpaulin required will be equal to the curved surface area of the tent, right? Tent इसी से तो बनाएंगे, right? So how this tent is actually made? From that tarpaulin material. So this material is actually make the curved surface area of the tent, right? So this is 188.4 meter square, right? Now width of the tarpaulin is already given here, right? So the tarpaulin having width which is 3 meter and this is fixed, and now we have to find the length, right? So now width is given for the material, right? Area we have already find it out, which is the curved surface area of the tent. Now we can find out the length. Are you getting that? So write down width of tarpaulin is 3 meter. This is given, right? Now we can find out the length. Length required of tarpaulin, that is area upon width. So if you divide area by width, you can get the length, right? Because area is length into breadth. So if you need to find out the length, you can divide the area with width. So 188.4 divided by 3, right? And this is equal to 62.8 meters. So this is the length of the tarpaulin required. Is that clear? Now, but it is given here that some material of the tarpaulin is actually wasted in stitching, margins and in cutting, right? Because when we make the tent, we need to cut that tarpaulin material. We need to stitch some material, right? So some material will get wasted into that, right? So what is that extra length? So extra length required, right, for stitching and wastage, right, for cutting and all, this is 20 centimeters, right? Or you can say 0.2 meters, right? So this is the extra material required for stitching and the cutting, right? And length of the tarpaulin required to make the tent is 62.8 meter, right? So now you can find the total length of tarpaulin which is required to make the tent is equal to addition of both, that is 62.8 plus 0.2 meters, that is 63 meter, right? So from this tarpaulin, if we want to make a conical tent, right, of the given specification, that is the base radius 6 meter and the height 8 meter, then the total length of the tarpaulin required is 63 meters, whose width is fixed, that is 3 meters. Is it clear? So here we are finding the length, right? It is exactly similar when you go to the market, to a shop, to the cloth shop where you are taking the stitching material, right? So its width is always fixed. What you can actually ask for the shopkeeper to cut it through the length only, right? Because width of that material is fixed. So similarly here, tarpaulin width is fixed, that is 3 meter. Now we have to find the length of the tarpaulin which is required to make the conical tent, right? So curved surface area of the conical tent will be equal to the area of the tarpaulin required, right? And its width is already given. So we can find out the length. That will be the length required to make that conical tent, right? Plus extra length, which will get wasted in the stitching and the cutting of that tent. Is that clear to everyone? Yes or no? Now look at this question number 5. A corn cob shaped somewhat like a cone has the radius of its broadest end as 2.1 centimeter and length as 20 centimeter. If each 1 centimeter square of the surface of cob carries an average of 4 grains, find how many grains you would find on the entire cob. So first understand the question. What is corn cob? Corn cob is bhutta, right? The corn which you generally eat during the spring season, right? So this is the corn cob, okay, bhutta, which is shaped like a cone, right? And if you can see here, I have made the diagram. So this is the corn cob. Just a second. So this is the corn cob and it is like a cone. So I have made a cone also here, right? Now the broadest end is 2.1 centimeter. The radius is 2.1 centimeter. That means this to this, right? Suppose this point is A, right? And this is B, right? So AB here, the radius means radius of the cone is 2.1 centimeter. Okay. And height of the cone, right? This is the height, right? Height of the cone, right? Means length. Length means here height, right? So it is 20 centimeter, right? Is that clear? So this is given here. R 2.1 centimeter and H is 20 centimeter, right? So here the grains on the cone we have to find, and this grain is where these grains are actually placed, right? Where they are actually, you can found these on the curved surface area, yes or no? So whatever grains are there, it is on the curved surface area, right? On this area, getting that? Here actually cones are attached, right? So we have to find the curved surface area. And now since it is given that for every 1 centimeter square area, there are 4 grains. So we can easily find the number of grains, right? So first we will find out the curved surface area. Now to find the curved surface area, we should know the slant height of the cone. So first we will find that L, the slant height, right? Means this one, that is square root of R square plus H square, right? Now find it, 2.1 square root of 2.1 square plus 20 square. Is that clear? Right? So this is equal to 404. Just calculate this. 2.1 square is 4.41 and 20 square is 400, right? And therefore it is equal to 404.41. Is that clear? Square root of 404.41. And this is approximately 20.11 centimeter, right? So this is the slant height of the cone, right? So this is the slant height of the cone. Now, since we have got the slant height of the cone, we can easily find the curved surface area. So curved surface area of the cone cob, this is equal to pi RL, right? Pi is 22/7. R is the radius, which is 2.1 centimeter into L, which is 20.11 centimeter, right? So now you can find it. So this is 0.3. You can cut 2.1 with 7. Now multiply all these. So 20.11 and 22 into 0.3. So this is approximately 132.73 centimeter square, right? So this is the curved surface area of the cone. Curved surface area of cone. Understood? So what we have found out, the curved surface area. Now, where these cone grains are actually present, it is present on the curved surface area. ठीक है? Cone उस कॉप के curved surface area पे तो लगे हुए हैं वो सारे grains, right? So that means because it is given here in the question that number of grains on 1 centimeter square means 1 centimeter square पे कितने grains हैं? 4 grains हैं, right? So number of grains on 1 centimeter square is 4. Therefore, number of grains on entire cone cob means on its surface area, curved surface area. Okay, this will be equal to the curved surface area, that is 132.73 into 4, right? So 1 centimeter square have 4 grain. So 132.73 centimeter square will be having how many grains? You have to multiply that. So 132.73 into 4. Is that clear? Right? Which is 530.92, or you can say 530, approximately 530 grains. Right? So how many grains are there in the on the entire corn cob? Means on the entire corn surface area of the corn cob, that is 530 grains, because 1 centimeter square, on 1 centimeter square there are 4 grains, right? So you can say 4 grain per centimeter square, right? So 4 grains per centimeter square, right? That's the reason the centimeter square will cut and you will get the number of the grains, right? So this is the answer. Is that clear? Okay, this is your NCERT question. Example number 3. Example number 3, NCERT. I think page number 140. Okay. So now in this question number 6, a hollow sphere of external and internal diameters 8 centimeter and 4 centimeter respectively is melted into a cone of base radius 8 centimeter. Find the height of the cone, right? So that means there is a spherical shell which is given here, okay? And this spherical shell is melted and a cone is formed by it, right? Okay, so what are the quantities which are given here, right? So for the spherical shell, the external and internal diameters are given, right? So external radius you can find of the spherical shell is diameter upon 2, right? So since it is 8 centimeter, so 8 centimeter by 2, that is 4 centimeter. This is the external radius. Now you can find the internal radius. Internal radius of the spherical shell, this is 4 centimeter by 2, that is 2 centimeter. So these are the internal and external radius of the spherical shell, right? It is somewhat like this, right? So this is the spherical shell, or you can say hollow sphere, right? Having the radius, which we have got here. So external radius, that is the capital R, and this is small r. So external radius is your capital R and internal radius is your small r, right? Now we know that the volume of the spherical shell is, volume of spherical shell is 4 by 3 pi capital R cube minus small r cube. This is the formula we have learned, right? 4 by 3 pi capital R cube minus small r cube. So we can find it out. 4 by 3 pi, capital R is 4, 4 cube minus small r is 2, 2 cube, right? Now solve this. So what you will get? 4 by 3 pi, right? So this is 64 minus 8, right? So what it will become? What it will become? So 4 by 3 pi into 56, multiply That is 224 upon 3 into pi, right? This much centimeter cube. This is the volume of the spherical shell. Is that clear? This is the volume of the spherical shell. Now this spherical shell is melted and a new solid is formed, that is the cone, right? But for that cone also, volume will remain same, right? So volume of cone is equal to volume of spherical shell because same material is melted to form the cone, right? Therefore, its volume of cone will also be 224 by 3 pi centimeter cube, right? Okay. So write down 224 by 3 pi centimeter cube. This is equal to, now what is the formula of the volume of the cone? Volume of the cone is 1 by 3 pi r square h. This is the formula for volume of the cone, right? So now you can put the value here, 1 by 3 into pi into r square. Now what is the radius of the new cone or the cone which is formed here? That is 8 centimeter. 8 centimeter is the diameter. So radius will be 4 centimeter, right? Okay. So radius of cone is 4 centimeter, right? So now put here, the radius of cone is 4 centimeter. So it is 4 square into h, and this is 224 by 3 pi. Right? Now from here we can easily find the value of h. Pi will cancel, 3 will cancel. So h is equals to 224 upon 4 square, right? That is 16, 224 upon 16. Is that clear? Right? So you can cut this, and this is 14, right? So h is equals to 14 centimeters, right? So using this method, we can easily find the height of the cone, right? So write down, hence the height of the cone is 14 centimeter. So always remember, when one material is melted to form a new solid, a new shape, right? Volume always remains same, right? Its surface area, its total surface area can be different, length can be different, height can be different, radius can be different, but the volume, because volume is the total material by which you are actually forming the solid, right? So volume always remains same, right? So the volume of the spherical shell, the spherical hollow sphere, and the volume of the cone, right? Both having the same material. Getting that? And that's the reason the volume is same. So we can find the volume of from the one solid, and that will be the same for the new solid. And using this, we can easily find the height of the cone. So I hope you have understood now, like how to do this question.